Hello and welcome to the demo video, part one for our final project. In our final project, we are essentially comparing the analytical metrics of two models, which is ImageNet and DetectNet. And for the first one, for our first part, for ImageNet, we are using two different models of ImageNet, one being AlexNet and one being GoogleNet, and we are using the same data set that we downloaded off of Kaggle, consisting of various fruits, and we're going to essentially pit them against each other, see which one's more accurate, which one, essentially is overall precise, and a couple other different metrics to essentially evaluate how its performance, whether that's F1 score or so on and so forth. So to begin, we're first gonna change into our into the right directory. So now being in the right directory, we're just going to simply open up our code. So this is the first one being GoogleNet. And the image on the left is the image that we are currently trying to classify. As we can see here, it currently classifies as a Granny Smith, which it is, a green apple, with 99% confidence. And it also lists things such as processing time, precision, recall, F1 score. And now we're going to pit it against the AlexNet model. And as we can see, it also classified it pretty strongly as a Granny Smith. So now we're going to move on to our next class, which is a banana. And so it did pretty well on this one as well for the GoogleNet. And now we're running the AlexNet. Keep in mind, in the last model, it's set at 99% precision rate. And this one, for the AlexNet, it recognized it with a 100% confidence rate. So we do see a little bit of fluctuation between the accuracy, the confidence, and overall other metrics. We're now gonna move on to our next class. So as we can see here, for this orange right here, the GoogleNet classified it obviously as an orange with a 98% confidence rate. And now when we do AlexNet, it also classifies it as an orange, but with a 93% confidence rate. Now we move on to our next class, which is a kiwi. And again, we're going to start with the GoogleNet. And it actually classifies as a lemon for some reason. Obviously, it doesn't look like the lemon, and it has a very low confidence rate for obvious reasons. And now we're going to do the AlexNet to see if we get a different result. And we did indeed get a different result, but now it's saying it's a tennis ball. So maybe both models, just were lacking in data set. Images for the kiwi maybe needed to be trained a little bit longer for the kiwi, or refined. I mean, I can kind of see the resemblance in a tennis ball just because it's green, but as far as the other one, as a lemon, that doesn't really make sense to me. But we are now going to go to our final class, which is a strawberry. So we are now going to go to our final class of strawberry. So for the Google Net, for this image right here of a strawberry, it does locate it as a strawberry with a 99.7 confidence rate. And for the AlexNet, we get 100% confidence rate. And again, you know, for all these different models, we do have all these different metrics. Like I said, top 5 predictions, processing time, precision, recall rate, F1 score, and all this, you know, will be shown in the table that's in our slides. But yeah, so, you know, the whole, I guess, premise of doing this for our first part was to see, okay, we're using ImageNet as, you know, the base idea, but how do the different models, I guess, classify things differently, and, you know, with different accuracy, different precision, different confidence. And that's just, you know, the way that they fine-tuned it and the way that they trained each model. And, you know, even though that they're comparing the same data set, they're both, you know, getting fluctuating results. And so now we're going to see 2 different DetectNet models, one being the standard DetectNet model that's trained just off of the, you know, regular GitHub. And another one is a DetectNet model that's specifically trained for fruits. And we're going to see the differing scores, the differing metric values that they both populate. So now we're going into our second model, the one that is specifically trained to class or to recognize fruits. So as we can see, we're showing it the same image, but the confidence rate on this one is much, much higher. This is at a 99.8, 99.7. And if we stop the terminal, we're able to see these stats over here populate. Like I said, precision, recall rate, F1 rate, false positive rate, true negative rate, or true positive rate. It classifies the object, it tells you the confidence, so on and so forth. And it also gives a little bit of specs pertaining to the CPU usage, and, you know, where in the process the CPU is used. But yeah, so we're kind of just going to go through each of our 5 classes in the DetectNet and compare them from the original model to one that's trained for fruits and see the differences. So as previously mentioned, we're just going to kind of go through each of the classes that we have for comparing both of the DetectNet models. So first we have the apple, which we can see right here has, you know, a bit of a fluctuating rate, but, you know, the closer that the camera goes into the object, we see that, you know, that rate gets a lot higher. Now it's in the 99s. But to the left, like I said, we have all that information populating with its precision score, the F1 score, the recall rate, so on and so forth. But as we can see, for the fruit trained DetectNet model, you know, it's doing what's supposed to. We're going to see it right now. Go switch fruits. So now this is now watermelon, and it's able to classify it pretty well. I believe that it might be kind of a little finicky just because there is, you know, a whole watermelon in the back and a sliced watermelon in the front. Perhaps that's causing the score to fluctuate in between each other. We're gonna go now to some grapes, and it is able to recognize the grapes as well. We are going to keep going, and this is now orange. Again, able to do it pretty well. Now we move on to pear, same. It's able to recognize it pretty well. Pineapple, all the same. You know, a lot of these scores They're fluctuating, but they're all maintaining above 80. We move on to a strawberry. And again, it's able to recognize a strawberry pretty well, although bounding boxes are overlapping. Maybe that's just because of the camera or the way that it's facing the object and therefore trying to compensate, and it's overlaying. And then this is the one where it's had an issue where if you face it from a weird angle, it'll classify it something else, but when it faces the banana from face front, it recognizes the banana and it classifies it as such. But again, that bounding rate, or not the bounding rate, but the confidence rate is fluctuating a lot for this item. But yeah, so as we can see in the terminal, these are all the rates and all the scores for the metrics for each item. So as you can see, if we stop right here, this is for an orange. For the orange, when we had it there, it has a confidence rate of 51. Again, these are populating like every second, and so for each time that it recognizes the object, it has a different confidence rate, obviously, and different scores. So we hope to put these all on a table and kind of get a mean like average of each thing, and kind of compare it against each model as we had previously mentioned. So now we're going to compare this to the regular DetectNet model and how it's trained, and see if it recognizes any of the fruits. So now we are going to open up the original DetectNet model and see how it pits against all the different fruit types that we have, as opposed to, again, the trained model that we had. So as you can see, this model was trained with various different classes, and therefore it isn't as finely tuned, and something as, I guess, is bundling clear, such as the apple, it's currently classifying as a mouse, and it's also trying to register the monitor of my laptop, and it's calling that a TV. If we look over here, we're able to see all these scores. Again, the precision score, the recall score, the F1 score, and because it just can't make up its mind, everything's at a 0 right now, except the false positive rate. And so we're gonna just scroll through these and see if we get anything. I mean, for this, it's saying it's a book. It's not really even locking into the watermelon whatsoever. So for these grapes, again, not even locking into it as it previously was for the apple. This orange, it's currently classifying it as a frisbee and a cup. Again, if a model doesn't know what to necessarily look for specifically, it's going to go with the next best thing. And so this model wasn't necessarily, I guess, trained to detect solely fruits, and therefore is trying to compensate for that. And again, we're here with the pear. We zoom in and it's classifying it as a bottle. We move on to pineapple, and it's currently classifying it as a vase. And we move on to a strawberry again, classifying it as a vase with a 92% confidence rate. And finally, lastly, we have a banana that it classifies as a cup. So it's very clear to see how, a model that's clearly trained, clearly refined, and retuned for specific recognition, will differ between a model that's general purpose based and, maybe is overloaded with images, overloaded in the training, and therefore, you can't use it for specific tasks per se. And yeah, so we hope to connect this back to our overall grocery store idea and how, these models need to be fine-tuned in order to be efficient, in order to optimize the overall, grocery buying experience. And, these models need to be further trained precisely in order to actually do well to, the whole scope of the problem.